Today I've got another problem from TBO's problem solving booklet. I'm quite enjoying these problems, and also they're quite seasonal given that Oxford and Cambridge maths interviews are currently happening. This problem here is to prove a very short one that pi is between 3 and 4. And well, you might think, well, surely pi is, everyone knows that pi is 3.1415926, blah, 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 blah. But that's not really a proof, right? We've been told that pi is between, what is that number? But why is pi in between that number? And there's a bunch of ways you can attack this problem. Some are a lot more complex than others. But 3 and 4 are relatively nice numbers. We're first going to start by showing that pi is less than 4, because pi, as we know, is 3.14, so it's quite far away from 4. So it seems a bit easier to prove that pi is less than 4. How exactly do they expect us to prove this? I mean, pi is just a number. We've been taught it since we're kids that it's 3.14. That's just what it is. But why? And then we think, hold on a second, when did we first learn about pi? Well, it was in geometry when you're talking about circles. So what we should probably have is a circle. So let's draw on a circle here. And let's put its center there. And let's make its radius 1. And so then we know that the area of this circle is pi. Okay, cool. Now, how can I show that pi is less than 4? Well, if I can show that the circle is enclosed within an object, and that object has area 4, then that will prove that pi is less than 4. Well, what object can I choose? Well, I can choose a square. So I try my best to draw this, but maybe a square that looks something like this. That's supposed to be tangential. So imagine that's a tangent there and a tangent there. And now if the radius of this circle is 1, that means the side length of this square is 2. And so the area is 4. And so we get pi is less than 4, like so. Nice and straightforward. Now let's prove that pi is bigger than 3. So now to prove pi is bigger than 3, we can use a similar technique, except now we need to find a shape that's inside the circle, and that has area 3. Now, again, in the real world, we do know that pi is 3.14. So 3 is relatively close to that. So this shape, if it is inside this circle, again, this has radius 1, it's got to be taking up most of this circle. Okay, well, what shapes could we try? We could try a square. There's almost certainly too much wasted space there. That's not going to have area 3. But then we realize maybe we can kind of continue. Let's not do a square, let's do a pentagon. So if I try and draw a pentagon in here, it might look something. Oh, this is a horrible pentagon, but something like that. But again, there's quite a lot of wasted space. And I could keep trying one by one and try and work out the area of each of these, but that's going to get quite messy. Can I generalize this? The answer is yes. Let's take an arbitrary n-gon. And the way we're going to do this is start from drawing a line from the origin up to here, and we're just going to equally distribute n lines around the circle. Like so. So this might be when n is 1, 2, 3, 4, 5, 6, 7. I don't know. So something like this. These are all going to be equally distributed around the circle. Let's say like so. And then we're going to connect these up to form a regular shape which has area just less than pi, like so. And we're going to ask ourselves, well, what is the area of this polygon? Okay, well, it's got n sides. How can we work out the area of this? Well, let's first think about this angle here. Well, the whole angle is 2 pi, and we've equally split it into n. So that's 2 pi over n. So what's the area of this n-gon? So the n-gon has area equal to, well, it's just going to be n lots of the area of this triangle. What's the area of that triangle? Well, I can just use a half times a times b times sine of the angle. So it's a half times 1 times 1 times sine of 2 pi over n. And so if we just simplify this, this is just n over 2 times sine of 2 pi over n. Okay, great. So now I just need to play around with values of n until this thing here gets to be 3 or bigger. And now the only issue is, at least in an interview, you're not given a calculator. Um, And so, and in an ideal world, you probably just make n a million, right? Because this obviously, as you make n bigger and bigger and bigger, this n-gon fills up more and more of the circle. But of course, I don't know off the top of my head what sine of 2 pi over a million is. And it's going to be a very small number. So we need to try values of n that I do know. And now you could just play around with this, but we can be sensible. In an interview, what values of sine are we expected to know? Well, we're expected to know 0, 30, 45, 60, 90. And then, of course, like adding pi and things like that to these angles. But these are the acute angles we're expected to know, and obviously in degrees here. And now, in order to make this area as big as possible, as we say, we need to make n as big as possible. And that corresponds to making this angle as small as possible. But of course, clearly this is always positive. What's the smallest positive number in this list here? 30 degrees. 30 degrees is pi over 6, so we want 2 pi over n to equal pi over 6. So let's try n equals 12 and see what happens. Very conveniently, when n equals 12, this is just 12 over 2 times sine of, 2 pi over 12, which is pi over 6, which we know is a half. And so this is going to be 12 over 2, which is 6 times a half, which is 3. So the area of a 12-gon, don't even know what the name of a 12-gon is. Is it decagon, dodecagon, something like that? The area of it is 3, and obviously the circle is slightly bigger, and so pi is therefore bigger than 3. And that's how you prove that pi is between 3 and 4. Very interesting. I think this is quite cool, and it's certainly a useful thing to know, knowing bounds on these common constants. So see if you can do something similar for E. See if you can prove that E is between 2 and 3. Obviously slightly different because E isn't normally defined geometrically. So have a go at that. Anyway, we'll leave this problem here. Best of luck if you are looking to prepare for your Oxford and Cambridge maths interviews. I know that very soon some of you may have already done some by now, so best of luck if you've got some, and hope they all went well if you have done them already. Do let me know if you do want some support with your interviews or interview preparation. But apart from that, best of luck with everything. Thanks so much for watching. I'll catch you in the next one. Have a great day.